Okay, so this is a little bit of a challenge to try to figure out what this assigned area is going to be, because that's not a line. The previous examples that I gave you, we had lines, and lines gave us nice triangles, trapezoids. I suppose if we'd had a horizontal line, we would have gotten a rectangle. Okay, here, this isn't a line, but that is the function y equals the square root of 4 minus x squared. Okay, and it's going to be a little bit easier to recognize the shape of that curve if I get rid of the square root. So I'm going to square both sides of this. I'm going to say y squared is equal to 4 minus x squared, but I'm going to also record that y is bigger than or equal to 0. Because when I squared both sides, I don't want to lose that information. I can see from this original equation that y can't be negative, because y is defined to be the principal square root of 4 minus x squared, and that's always going to spit out something that's not negative. So y still can't be negative. But now if I add over the x squared, I get x squared plus y squared equals 4, and y is bigger than or equal to 0. That looks familiar. That's the equation for a circle of radius 2. Careful, the radius isn't 4, that's the radius squared. This would be a circle of radius 2, and because y is bigger than or equal to 0, it's just the top half of that circle. So it would go from negative 2 over here to 2 over here. So that's the graph of my integrand, the function here that I'm integrating or that determines the height of my shape. Now, we were going just from negative 2 to 0. So I actually only care about this part of it right here. And that's going to be a positive area because it lies above the x-axis. I don't care that it's to the left of the y-axis. The base, as long as I'm integrating from left to right, and eventually we'll define that we can go backwards from right to left, but for the time being we're always going to be going from left to right. The base counts as positive. What determines whether it's positive or negative area is just whether it's above or below the x-axis. So now I can look at that and I say, that's a quarter of a circle. So that area is going to be 1/4 of pi times my radius squared, where my radius was 2. So that's 1/4 of pi times 4. That's just pi. So you want to be on the lookout for functions like this that describe half of a circle. If I wanted the bottom half of the circle, I'd just have a negative sign in front of that square root, because that would be saying that y is not positive instead of saying that y isn't negative. All right, so that one was kind of tough. I'm going to give you another one that's related, but that tweaks it just a little bit. See how you do with this one. So let's try the integral from negative 3 to 3 of 4 minus the square root of 9 minus x squared dx. And I'm just going to give you one hint before I suggest that you pause the video. Might help to think of this as negative root 9 minus x squared. Figure out what that is first. Figure out the shape of that. And then we're adding 4 to it. And what that adding 4 is going to do is just move things up 4. So I'm going to try to think of this as a vertical translation up 4 units of whatever this curve is. Okay, so with that, give it a shot. Pause the video, see if you can calculate this signed area. Then tune back in and we'll do it together. Welcome back. Okay, so I'm going to follow my own hint. I'm going to start with y equals the square root, negative the square root of 9 minus x squared. Now if I square both sides, that becomes y squared equals 9 minus x squared, and y is less than or equal to 0. Okay. So I'm going to recognize that that is the bottom half of a circle of radius 3. So we would go from negative 3 to 3, and that's just y equals 9, sorry, the square root, negative the square root of 9 minus x squared. Now what we're doing is we're adding 4 to that. What that's going to do is shift everything up 4. So instead of this point being at negative 3, 0, now that point is going to be at negative 3, 4. Instead of this point being at 0, negative 3, now we move that up 4, that point is at 0, 1. And instead of this point being at 3, 0, we're going to move that up 4, and so we're at 3, 4. So we've still got a semicircle, it's just a semicircle that's been lifted up so that it lies above the x-axis. So now, that's going to be my ceiling. The x-axis from negative 3 to 3 is going to be my floor. I'm allowed to draw in the walls. So I've got this shape right here. Now I don't have a single formula for that shape. I can recognize that this is going to be positive area because it's all above the x-axis. I'm going to view that as the rectangle minus the semicircle. If I had a line here, I could get this rectangle, and I'm just removing half of a circle from it. So this shape by itself isn't one that I have a geometric formula for, but that shape is one that I can build by combining things that I have a geometric formula for. So the base here is going to be 6. We shifted things up 4, so this height here is 4. And this is going to be half of pi times 3 squared, because it's half of the circle of radius 9. So that's going to give me 24 minus 9 pi over 2. That would be the area that I get, the signed area, which in this case, because it's all above the x-axis, the signed area and the geometric area are the same, but that's not always the case. If I've got any negative area, signed area is very different from geometric area. Okay, good stuff.